Hello everybody, how are you? Wish you are doing very well. Today inshallah we will continue our lesson about solutions. So yesterday, you remember, we discussed about the differential solution, and we say that mixtures can be either solution or suspension or colloid, and we discussed the different properties of each of these mixture. And then we say that the solution is made up of two main parts, solid and solvent. And today inshallah we're gonna talk mainly about something called concentration. We will talk about concentration of solution and how can we calculate concentration of a certain solution, and we will discuss about the different kind of solution in terms of their concentration. And then inshallah we're gonna discuss about the factors that will affect the solubility of certain solid in a given amount of solid. So let us start guys first with the meaning of concentration. Concentration is the measure of the amount of solid dissolved in a solid. So basically it's a relationship between the amount of solid and the volume of the solid. So again, concentration is the measure of the amount of solid dissolved in a solid. So how can we calculate the concentration? One way to calculate the concentration of a solution is to divide the mass of the solid by the volume of the solid. So as we said, concentration describes the relationship between the amount of solid and the amount of solid, and usually we use or we describe the amount of solid using its mass, and we use the volume to measure the amount of solvent. So the rule would be concentration is equal to mass over volume, mass of solid over volume of solid. And now what about the unit, guys? As we know, the mass is measured using what? Using grams, while the volume of solvent, for example volume of water or any other solvent, is expressed using what? Using milliliter. So the unit of concentration will be gram per milliliters. Okay, so now as we said, solutions can be, or any solution can be categorized into three different types according to the amount of solid inside each one of them. So we will categorize a solution according to their concentration into dilute solution, a concentrated solution, and a saturated solution. So let us start with a dilute solution. As you can see, guys, in this photo, we have three beakers, and as you can see, the amount of water here in this beaker is equal to the amount of water in the other beakers. So the amount of water or the amount of solid that we are using is equal. What about the amount of solute? The amount of solute will be changed. Okay, guys, so the amount, and for example in the first beaker the amount of solute is small, and then we will increase it gradually as we go down. So for the first type of solution, which is the dilute solution, we are adding a small amount of solid, guys, to, for example, 250 ml of solvent or of water. So that's why we are saying that this solution is a dilute solution. Why? Because this solution or this solvent contains a small amount of solid. What about, guys, the other beaker here, the next beaker? As we can see, we increased the amount of solid, but the amount of solvent is still the same, 250 ml. So now, what do you think? What will happen to the concentration of the solution? Yes, the concentration of the solution will increase, as we can see from this color. That's why we call it a concentrated solution. And guys, you may remember that we say that the solid that will be added to a solvent will evenly distributed through the solvent molecule. So here, because as we know, there is spaces between the water molecules, so now that these spaces will be filled up with what? With the solid particles. Okay, so as we increase the amount of solid, the spaces between the water molecule will decrease, and we will keep adding solid until there is no spaces, until there is no empty spaces. So at this time we will say that we reached a saturation level. A saturation level is when you keep adding solid, but then this solid will not be able to dissolve and will not have any spaces to occupy. Okay, so guys, again, what do we mean by a saturated solution? Saturated solution is a kind of solution that contains the most solid that can be completely dissolved in a given amount of solvent at a given temperature and pressure. So again, guys, let us see here. We can't recognize the particles of solid as they all dissolved in the solvent. The same for the concentrated solution. In the concentrated solution, we have a large amount of solid, but still there is spaces between the water molecule that in which these particles can occupy. So here we will never see the solid particles. Okay, they will evenly distributed through the solvent, but as we increase the amount of solute, the spaces between the water particle will decrease, and we will reach a level in which there is no spaces between water particles, and the solid that you are adding will not be able to dissolve, and it will start to what? It will start to settle to the bottom of this beaker without dissolving, and at this level we can say that we reached a saturation level, and the solution that you will have here called a saturated solution. So a saturated solution contains the most solid that can be completely dissolved in a given amount of solvent at a given temperature and pressure. And if we keep adding solid, the added solid will not dissolve, and it will what? It will settle to the bottom without dissolving. So now let us discuss about the factors that affect solubility. But before that, let us define what do we mean by the solubility. The solubility of a solid is its ability to dissolve in a given amount of solvent at a certain temperature and pressure. So as we know, some substances can easily dissolve in certain solvent while other substances cannot. So here we need to discuss the factors that makes certain solid able to dissolve better than others. Okay, so as you can see here, guys, the two main factors that will affect the solubility is the temperature and the pressure. So guys, for the first factor, what do you think? How could temperature affect the solubility of certain solid? So for temperature here, we need to be careful that the effect of temperature on solid solids is different than the effect of temperature for gases. So for example, for a solid, as the temperature increases, the solids will dissolve better. So for solid solids, the increase in temperature will increase the solubility, while for gases the opposite is true. An increase in temperature makes a gas less soluble in water. So for example, the sugar particles or salt particle can dissolve better in hot water, while for example for oxygen will dissolve better in cold water. So what about other factor that will affect solubility, guys? We have the pressure, as we said. So for pressure, guys, pressure changes do not usually change the solubility of solids or liquids. So any change in pressure will not affect the solubility of solids or liquids, but it will affect the solubility of gases. So for gases, guys, the solubility of gas will increase at higher pressure, and it will decrease at lower pressure. So again, guys, the pressure change will not affect the solubility rate of solids or liquids, but it will affect the solubility of gases. As the pressure increase, the solubility of gases will increase, and as pressure decrease, the solubility of gases will decrease. So now, guys, let us try to answer this question. Use this table to answer the following questions, and here we will answer only question number 9. So as you can see here in the table, we have 3 different types of solid: sodium chloride, and we have potassium nitrate, and we have sodium sulfate. And here we have the solubility of each of these solids at different temperatures. We have the solubility of the solid at 25 Celsius and at 100 Celsius. So now let us study the solubility of each of these solids at these different temperatures. For sodium chloride at 25, the solubility was 36, while when we increase the temperature to 100, the solubility, as we can see, slightly increased to 40. What about, guys, potassium? For potassium, you can see that at 25 Celsius it was solubility was 39, and at 100 it increased to 246. So we have here a significant increase in the solubility rate for potassium nitrate. What about, guys, the third solid? We have sodium sulfate. For sodium sulfate, the solubility was 20. Then, as we can see here, it decreased to 0. Okay, so the question is, how does an increase in temperature affect the solubility of each compound in 100 grams of water? Guys, as we can see, for the first 2 solids, for sodium chloride and potassium nitrate, the increasing in temperature increased the solubility, while for the third compound, which is sodium sulfate, the increase in temperature result in a lower solubility. Okay, so the answer will be, guys, as following. Let us try to write the answer for you. So, guys, here's the answer. As temperature rises, the solubility of potassium nitrate and sodium chloride increase, but the solubility of sodium sulfate decreases. So that's all for today. Thank you, guys, and see you tomorrow, inshallah.